right, good morning, everyone. So I guess we'll just get started. Just a couple of you guys are still on the way to get online. Um, so let's see, a couple of reminders here again. Number 3 homework is due on Thursday. Okay, so still about 3 more days to go, but time flies fast. Okay, I see some of you guys have started working on them, and then I even saw one has completed number 3. That's great. Okay, but get started as soon as possible if you haven't done so. The second reminder is the exam 1 is next week. Okay, so if you are in seat on Wednesday, you will take the exam 1 on Wednesday. If you are in seat on Friday, you'll take the exam on Friday. Okay, so let's take on the lecture today. So briefly, last time we talked about adding 2 vectors or more. I think we talked about adding 2 vectors, okay? But the same will apply if you're adding more than 2 vectors together, saying if you are adding 3 vectors or 4, okay? So analytically, what you want to do is you find the components of each vectors to be added, and then you add the x and y components separately to get the x and y components for the resultant vector. Okay, so once you have the components of resultant vectors, then you can solve for the magnitude and also its directional angle. Okay, so a straightforward way to do it. We can also talk about another way to do vector addition. You can do it by using laws of sines and law of sines and law of cosines. Okay, because if you are adding any 2 vectors up, then you'll form in addition to a resultant vector, the 3 vector will form a triangle. And then you can utilize those 2 laws, okay, to figure out the magnitude and directional angle of the resultant vector. All right. So we'll also do an exercise using laws of sines and cosines in the lab this week. Okay. So for some of you guys, you might not be able to attend the lab, but you can check on the lab manual already post online to see this. Okay. If you want to take an earlier look on the what is in the lab. Okay. All right, and then last time we also talked about addition of velocities. Okay, so for a velocities addition, you can use subscripts to represent the vectors, the velocity vectors. Okay, so object 1 relative to another, let's say object 2, and then velocity of object 2 relative to object 3. So if you do velocity of 1 with respect to 2 plus velocity of 2 with respect to 3, then the resultant will be the velocity of 1 with respect to the 3. Okay, so that's how you want to use the subscripts here. Now the figure shows here the subscripts are in numbers. You can also do the subscripts in letters. Okay, so similar rule apply there. If you switch subscripts, then you get a negative vector, or you just revert the direction of the original vector. Okay, so in that way, if you are doing vectors subtraction, then you can also convert it into a vector addition. Okay, or in sometimes you just know one vector, but you actually wanted negative of that, or in the opposite direction. Okay, so then you can just put a negative sign in front of it. All right, so I think that's pretty much all. Actually, I think we start with the 2-dimensional motion last time. So we look at the turtle traveling in one line, which form an angle with the x direction. So then in this case, you can do the motion in 2-dimensionally, like x direction and y direction. So you just have to do it twice, okay? But so then you can do either, you can get the resultant or the overall displacement first, then solve for the x and y displacement separately, or you can do the x or y displacement directly by doing the velocity times time t. Okay, so on the figure here, the 2 methods are equivalent to each other. So in this case, if your oscillation is equal to 0, meaning you are having constant velocity, just like the turtle did in the previous slide. Then your position as a function of time t only then depends on the initial position and then the initial velocity, okay? And then the time t. So then it becomes the second equation here, x equal to x naught plus v0 t. So you can, again, you can solve this by looking at the velocity components, okay? So then you'll be doing v0 cosine t, okay, plus x naught to be the x position, y naught plus v0 sine theta t to be the y, okay? So you can use these basic equations for constant velocity, okay? So let's take a quick look on the example here. So you guys can go and go ahead and give it a try, okay? We can look at the solution together just in a couple of minutes, okay? As you guys working on the practice here, let me make a comment on the homework problems. Okay, so um, some of you guys probably like when you look at the homeworks problems and then um, didn't know like how to solve a particular problem. So um, some of you guys try, some of you guys just give up. Okay, I didn't try anything, but I would encourage you at least try it out. Although you might not get the full credit if you didn't get it right. Expertise, I think most of the time will not give you credit if you didn't get it right. Okay, but still try it, because when I get a chance, I will look into what you have done. If you have tried, I will partially credit you. I can override what the system credit you. Okay, so just give it a try, even if you don't know how to solve a problem. Okay, you'll be partially credited. Okay, so I have done that for your first two homework assignments. Okay, so you can take a look. So usually you'll get certain credit on the problem if you try, even if you don't have the correct answer. Okay. All right, I think I'm gonna to just wait for about 30 seconds or so, then we can take a look at this, the solution for this one together. Okay. All right, so let's take a look at the solution together. Let me just stop sharing my screen so you guys can see my work on the paper better. All right, so this one says, as you walk to the class in a certain given day, say if you have a constant velocity of 17.5 meters per second, and you walk 18 degrees north of east. Okay, so then so this is what you are going to do. You're going to just sketch the problem. Okay, so say this is east, this is north. So usually we put the eastward direction in the horizontal to the right, and the north to the vertical upward. So then it says north of east. So that means you are measuring from east, but towards the north side. Okay, so in that direction. Okay, so you might have to get used to the wording here. So when it says north of east, that means it's measuring in that direction. Okay, so this is 18 degree, and then this is 1.75 meters per second. Okay, so you might have trouble with 18 degree north or east, but this is what it meant. Okay, so if it's say west of north, so that means starting from north and then going towards the west direction. So then in that direction. Okay, um, so these are just the terminology here. Um, it's asking you how much time does it take to change your position by A 20 meters east, and then B 30 meters north. Okay, so 20 meters east may be something like this here. So this is 20 meters. Okay, and then 30 meters north. So it's going to be somewhere like that. Okay, so you can see if you are going in this direction, then your displacement will go in that direction. So in this time, and then B that time. Okay, I probably don't have a quite well drawing. So this is much more than 18 degree. Okay, just in case you're wondering. This looks like something like 30 degree or so, but just give you a rough idea what's going on here. All right, so A here, it tells you this, the X is equal to 20. So this is the final X, right? We can set up your original position to be at the origin, which is X naught, Y naught. So X naught is 0, and then Y naught is 0, okay? All right. And then V naught is, or V is that because it's constant velocity. So it's V naught, or you can just say V, it doesn't change, okay? So then you can look at the equation for the position in X. So X is equal to X naught plus V0 X, right? Which is V0 cosine of the directional angle times T, okay? So you can check on the previous slides for the equation here. So you are looking for T here. This angle theta is exactly the directional angle. Okay, so theta is 18 degrees. It's given. So you can see there's only one unknown here. You can solve for your angle for your time T. Okay, so what you want to do is, or before you arrange any of the terms here to see, let's check if any term is 0 here. So this guy initial position is 0, so you can drop that. Okay, so then tells you X is equal to V0 cosine theta times T. All right. So then solve for T, you will divide both sides by V0 cosine theta. Okay, divide that by V0 cosine theta. That will give you T. So your T is equal to X over V0 cosine theta. Okay. So X is 20 meters divided by V0, 1.75 meters per second, cosine of 18 degrees, okay? So then that gives me roughly 12 seconds, so 12.02 seconds, okay? Now, some of you guys might get a different number. Again, I would like to emphasize here. So one thing, a couple of things to check here. So because this is in degrees, check your calculator is set in degrees, not in radians, okay? And then second thing is when you do 20 over 1.75 cosine 18 degree, then when you're typing in your calculator, you type in 20 divided by parenthesis 1.75. If you put a parenthesis here, then cosine 18, okay, and parenthesis. You want to put everything in the denominator inside a pair of parentheses, okay? So that's, again, a common mistake to make, all right? Check if you didn't have the correct answer, so check on those two, okay? If you got to this point, okay? All right. So let's take on the second part here. It's asking you now how much time it does take to change your position by 30, okay, meters north, okay? So then again, now this time you'll be looking at the y direction. So you'll be looking at the position equation here in the y direction, okay? So then will be V0, the y component, you do V0 sine theta, okay, times t. So similarly here, because this guy is 0, so then this is 30, okay? So then y equals to V0 sine theta times t. Then t, you divide both sides by this guy, okay? V sine, so V0 sine gives you t equals to y over V0 sine theta, okay? So 30 meters over 1.75 meters per second, sine of 18 degrees, okay? So let's tells you 55.48 seconds, okay? Or roughly 55.5 seconds, okay? All right. Any questions you guys might have? So again, I'm by default, you guys are muted upon entry, but you can unmute yourself and speak up, okay? Or you can even ask questions in the chat. All right. So if you guys are clear with that, then we can move on here. So this practice problem is when you have no oscillation, meaning constant velocity, okay? Now, in case if you have oscillation, okay, so then then you add the term that has oscillation in the equation of motions, okay? So again, we are just looking at 3 of the equations for each dimension that has oscillations. So then this guy, again, you'll be doing the looking at the equations in x direction and y direction separately. Okay, so in the x direction, then simply it's x naught plus v0 in the x component t plus 1/2 ax, the x component of oscillation times t squared. Okay, so you will break the velocity into x and y component. You will also break the oscillation into x and y components. Okay, so that's also a vector. You break it into the x and y components. So then your velocity has an x component, which is equal to its initial x component plus the oscillation in x component times t. All right. And then the last equation that has the oscillation in it, it gives you velocity in x direction square, the final square, and then the initial x component square plus 2 times oscillation in x component times delta x. That means the change in position. Okay, so delta x is x minus x naught. Similarly for y directions, okay, you add the y, the turns, the oscillation turns in y directions, okay, for the equation of motions. All right. So on this one, again, let's take a look on an exercise here, all right? So I will have you guys to do this, but this time I'm going to do it differently, okay? So I'm going to set up breakout rooms so you guys can join the breakout rooms and then having discussions on how to solve this one and then solve the problem together, okay, within your rooms. So I'm going to create, let me see, 10 rooms here. So you guys are automatically assigned, okay? So you'll have 3 of you guys in one room most of the time, and then one room will have, oh, actually just 3. Yeah, okay. All right, so you guys will receive a notice to ask you to join the room. Okay, so then join it. If you have questions in your room, you can raise your hand. I think there's a not call raise your hand, but something like ask your host or something in the more options. Okay, go ahead and then do that. And then after you guys are done, you can come to the main room. If you don't see me in the main room, that means I'm probably in one of the breakout rooms. Okay, just wait until I come back, okay? Until I come back, do not leave the meeting yet, okay? I'll give you guys about like 5 minutes on this one, okay? So create the rooms and then open the rooms, okay? Go ahead and join your rooms. You guys need to unmute yourself and talk to each other, okay? All right, I think you're all back here. So maybe I can wait another 30 seconds or so to let you guys submit any of your results, okay? All right, so you can continue to submit, continue submitting your results online, but we'll take a look together here now. So I put the equations of motions that with the ones with the acceleration in it from the previous slides down here. If you can also pull out the PowerPoint slide, you can go there. But I'm going to stop sharing here. So it will help if you pull out the PowerPoint slides on your end, okay? So, and this one, it says a skate border travels a horizontal on a horizontal surface with initial velocity of 3.80, okay? So then we are given V0 equals to 3.8 meters per second, says towards the south direction, okay? So that means this is, now let's do a sketch here so to see it clearly. So the south direction, so we will take that as the downward direction because north is upward, so south is downward, okay? Then east is in that way. So it says V0 is in the southward direction, okay? So in that direction. So that means this guy actually is just the V0 Y component, and then it's negative because it's in the southward direction, okay? And its X component that will be 0 because it's only going in this direction, okay? The Vy, or let me do Vy here. It's only in the southward direction, so it only has the Y component, which is negative. It doesn't have X component, all right? Now it says also it has a constant acceleration of 2.2 meters per second square towards east. So then acceleration is in this direction, acceleration, okay? So it's only in the towards east, so that means it only has X component. So acceleration X component is 2.2 meters per second. Its Y component is 0, okay? Because it's on the X direction only. And it says let X direction to be eastward and Y direction to be northward. Okay, so exactly as we set up, it says let the skateboarder be at origin at 0, t equal to 0. Okay, so original t 0 is equal to 0 second, and then original position it says is at the origin, so that means X naught and Y naught, they are both zeros. Okay, so I think that's the information we have. Now we are looking for what are her X and Y positions at t equal to 0.80 second. Okay, so then you look at the equation of motions, you are looking for X position and Y position. Okay, so you can use this X equal to X naught plus V0 X times T plus 1/2 AXT square. Okay, that's the first equation in the previous slide. So then this guy is 0, the X naught is 0. Okay, and then let's see, V0 V naught X is also 0, so the second term is also 0. Okay, so then your X is simply equal to 1/2 AX, the 2.2 meters per second square, the square on the acceleration, times 0.80 second square. Okay, so then you plug in those numbers in your calculators, it will show you this is 0.704 meters, or you keep 2 digits, 0.70 meters. Okay, So this is your X position, and then the Y position, again, you do similarly, Y naught plus V naught Y times T plus 1/2 AY T square, okay? And then again, this guy is 0, but this is not 0, V naught Y is not 0, okay? So you keep that term. AY is 0, so then this term will go to 0, okay? So this is simply V0 Y, which is negative 3.8 meters per second, times 0.80 second, okay? So then this is equal to, if you plug in the numbers into your calculator, minus 3.04 meters, or roughly minus 3.0 meters, okay? So these are your X and Y positions, okay? Questions you guys might have? All right, good. So if not, then let's look at B here. It says, what are her X and Y velocity components at this time? Okay, so then you're looking for the velocity component. Okay, so you look on the table in the previous slides, it's going to be the second equations, X component and Y component. Okay, so then you're looking for Vx equals to V0x, the initial velocity at X component, times ax times t, okay? So again, this guy, initially v0x is 0, so then you only have the second term, which will be 2.2 meters per second square times 0.80 second, okay? That will give you 1.76 meters per second, okay? If you keep 2 digits, 1.8 meters per second, all right? Similarly, for the y component, it's Vy equals to V0y plus Ay times t. Now, Ay is 0, so it's equal to original V0y, which is negative 3.8 meters per second, okay? So these are the x and y components of the velocities, okay? Okay, any questions you guys might have? Okay, unmute yourself and then speak up, okay? So if not, then there's something in the chat. So can you explain why AY is 0? Okay, so oscillation in Y, in the problem is stated that the oscillation is 2.2 meters per second squared towards east, okay? So that means oscillation is along east direction only, right? So then it's only in the X direction because X direction is the east direction. Then oscillation doesn't have a Y component, or Y component is 0, okay? Otherwise, if it's not 0, it should have a angle with the east direction, okay? Certain angle, but it's on just on the X east direction, that means its Y component is 0, okay? And then similarly for the velocity, it says it's towards south. So it's only in the along the south direction, which is the Y direction, negative Y direction, okay? All right, let me know if that's not clear. Okay, so if not, then we'll move on here. So next section, or the last section in this textbook talks about projectile motion, okay? So in the previous chapter, we talk about free fall, which means you throw an object upward or downward, okay, in the vertical direction, then the object is having just gravitational oscillation on it. Now, in this case, because we expand the motion into the two-dimensionally, so then you can imagine that if an object is not throwing right upward or downward, it's going to be in general, you throw an object out in the two-dimensional X and Y plane. Okay, so what happens? So if the object is being thrown, say, at an angle with horizontal, okay, so then what happens? So those motion, this type of motion is called projectile motion. So in this case, the object is only, again, after it's been released, then it's only experiencing gravitational oscillation, okay? So then due to the nature of gravitational oscillation, it's having fixed magnitude of 9.80 meters per second squared, and then the direction of it is always downward. So that means the oscillation of the object is always going to be downward. So in the vertical direction downward, okay? So then in the horizontal direction, the object is not experiencing any oscillation. So that means oscillation is only in the y component, okay? So then in this case, or actually there's assumption here. So let's talk about the assumption here. So the assumptions are we ignore the air resistance. Okay, so you can imagine anything you throw in the air, it will experience air resistance, although it might be small if the object is heavy. Okay, but in some cases it's significant, like if you are throwing a very light object like a paper, a tissue, or whatever, like a feather. So then air resistance, it will be significant. Okay, so but in this case, we are taking the assumption that the mass or the object is heavy, so then we can ignore the air resistance, okay? So then in this context, unless otherwise specified, we'll take the assumption that we are ignoring the air resistance, okay? The second assumption is we take the G as the constant number, 9.80, okay? We are not considering the variation of G due to location, okay? So we'll take that just as constant. And then the third assumption is we are ignoring the Earth's rotation, okay? So we'll assume because the Earth is so big, on the surface of Earth, anything compared to the Earth itself is so big, so then we can ignore the Earth's rotation, okay? Later on in this semester, we'll talk about the rotation of Earth, okay? That has very small effect on the oscillation of a projectile motion, okay? All right, so with those assumptions, then if the object is being thrown, kicked, batted, or otherwise launched into motion, then there's the only determining factor for its path is the gravity. Okay, so then these are any object having this type of motion is called projectile motion. Okay, so then it has oscillation in x direction to be 0. It has oscillation in y direction to be 9.80 meters per second squared downward. Okay, if you pick upward to be positive y direction, then oscillation is negative 9.8 meters per second squared. Okay. So under this assumption, we can take a look here. So if you release an object, okay, so then AX is 0, AY is minus G, okay? If you throw an object with a certain angle, then AX is 0, AY is minus G, okay? Again, so either way, if it's released, it's thrown at the angle, or it's kicked at the angle here, so then it has constant oscillation of G just in the y direction, okay? So then in this case, you can work with the equation of motions again in two-dimensional x and y. In x direction is simply just a constant velocity motion. Okay, in y direction it's constant oscillation motion. Okay. All right. So if you break the velocities in x and y direction, you can see in the x direction it's going to be constant. It's not changing, but in y direction it's going to be changing under the influence of the gravitational oscillation. Okay, in the figure here shows here. All right. Now, okay, let me, it's small here, but in part A, in figure A here, you can see this angle, okay? So theta 0. So if it starts at the origin here, you can see the object being thrown up. And then when it comes back at the same level here at X, okay, you'll see that theta is equal to minus theta 0, okay? So you may want to take a note that, so these two angles are the same angle, but in the opposite direction. One is pointing upward with the positive x direction. One is downward or below the x axis. Okay. So then positive and negative. Okay. We may talk about this later. Okay. All right. So then for the motion equation of motion, so these are the equation of motions. Okay. So in the x direction, you go simply because ax is 0 and then in y direction is negative g if you pick upward to be the positive direction, okay? So then these are the equation of motions. All right, x equal to x naught plus v0 x times t, and vx component is constant equal to the original x component. Vx square is equal to v x naught square. Okay, so that's the same as the second equation. Basically, you just take the square root of it, of both side equations. Okay. Now the y equation, in y, the equations are y equal to y naught plus v0 yt minus 1/2 gt squared. Okay, so the minus sign, that means you are picking upward to be positive, so then oscillation is negative. Okay, similar on here is negative gt on the second equation, and then third one is minus 2g delta y. Delta y is y minus y0. Okay, so then those are equation of motions. All right. So let me see. So on this one, I think we still have a few minutes, so I will have you guys go ahead and then rejoin the breakout rooms, and then you can have discussions on how to solve for this one. Okay. So again, I'm having the rooms open again. You'll receive invitation to join the rooms. Okay. And then towards the end of the class, I will call you guys all back. Okay. Okay, so it seems like you're all back. So just a reminder that home for homework, which is due on Thursday. Okay, so you guys have SI sections on Tuesdays. Okay, at 10:20 in the classroom, also the lab room, the same room there. So 10:20, but you guys have to sign up if you want to come. If the thing is, if nobody signs up, then she's not going to show up. Okay, so make sure you sign up if you want to come to the SI section. So that's one. And then the second one is regarding the face shield usage in the lab. So last week I asked in our department meeting about the face shield policy. So they now, because we have inconsistent rules from class to class or course to course, so at this point, the rule is you have to be in the classroom to be divided by a plexi divider for you not to wear a face shield. Okay, so make sure you are sitting on the partners are sitting on both sides, or everyone is being divided by the plexi divider. So then you can just not wearing the face shield, but you do have to wear your face mask properly throughout the time. Okay, so that means cover all both your nose and then your mouth. Okay, so that's the two reminders or kind of like announcement items here. So I'll see you guys on Wednesday then. Okay, bye.